Hey, Geometry Nation. Mr. Mitchell here, working towards the end of the year, so I'm starting with something light. Come on, Ed! You've got to see things from another angle. I thought I'd put a sphere in here. Okay. Some might say, Mr. Mitchell, spheres, the round things. I mean, I thought this was the biggest part of geometry. It's a round thing. It's like the earth. It's like the sun. It's got to be a big piece of physics. People must study spheres, right? The coronavirus is a sphere. The earth is almost a sphere. Snowball's a sphere. Protons, neutrons, electrons, they're spheres, right? That's what they look like in the chemistry textbook. Yes, but here's the thing for math. There's not too much to a sphere. The radius is what we need for a sphere and a circle. If you have the radius, you have everything. From the radius, I can get a diameter, I can get a circumference, I can get an area for a circle, a volume for a sphere, a surface area for a sphere. Okay, the radius. This is a day, I think, which is going to find shorter periods in class, so the video is meant to be pretty short. I'm going to cover a couple of examples on our work, and I think you're going to find some success, a little accumulated knowledge, operation of the calculator, comfort with looking up of what a formula is if you're not sure, and the calculation of these is not going to be bad. We're going to do the volume and the surface area of a sphere. And when you see these goofy formulas, if you think, like, why on earth is it 4/3 as a fraction used in this? I have seen that question later in the math career. It's in calculus as a proof. So you have to go back through your geometry to prove how something works. Calculus is involved because calculus is good at rounded surfaces. Keep it in mind. If you find yourself still intellectually curious, advanced math could be for you. And for almost everybody in the room, you'll find something in geometry in the next few years that comes up where you're like, all right, I guess that was kind of helpful. Help me with the deck project anyway. I'm going to take my picture away. I'll see you when I see you. I'm going to take my joke away. Come on, Ed. You've got to see things from another angle. All right, here I am, top of the page. I'm going to put my name on it in case I lose it. Somebody will find it for me. I'm going to find the volume of each sphere here on the front page. I'm going to use calculator's version of pi. And I'm going to answer to the 100th, right? 2 decimal places to the right, if necessary. Here we go. Let's try the formula for the volume of a sphere. Let's put it up top. The volume of a sphere is equal to, you ready for this? 4/3 as a fraction times pi. Because it's round, we've got this pi ratio. And then radius cubed. Cubed. Because these are volumes. Well, I didn't memorize it the first time, Mr. Mitchell, so I'm going to write it again. 4/3 times pi times radius cubed, because it's a volume. And now we work with it. Some people like to put it in a parentheses just to make sure order of operations is honored. I like that. When in doubt, put a parentheses. Multiply that times the number pi, and then times our radius. Here is 2. 2 cubed. 2 times 2 times 2. Well, that's 8. Let's see. 8 times 3 times roughly 1. It's not going to be more than 40. I put that into my calculator, and I get 33.51. And this is in centimeters cubed. Not too bad. You'll find a little rhythm here. Okay, I'm not sure still. Volume is equal to 4/3 times pi radius cubed. All right, 4 over 3, parentheses if I'm not sure, times pi times this one. I'm going to put down a 9 cubed. Wait, hold on a second, Mr. Mitchell. 9. Wait a minute. Be careful of the images. This is probably the trickiest part on the day. My diameter is given as 18. I need to be smart enough to realize that if the diameter is 18, the radius is half that number, or 9. Take your time with that especially. All right, 4 over 3 times pi times, 9 cubed. 9 times 9 times 9, 81 times 9. Suddenly, with the growth in radius from 2 to 9, watch what happens to the number. 3,053.63 meters cubed. When that radius starts to grow, your volume jumps in a large way because of the tripling of numbers, the cubing of numbers. 9 times 9 times 9. Good job, team. There's 2 down, 8 total on the front. You'll find the use of this formula. Okay, I'm going to flip over and I'm just going to go directly to the surface area of a sphere. Find the surface area. Use calculator for pi. Round answers to the 100th, 2 decimal places if necessary. The surface area for a sphere is actually a little simpler as a formula. 4 pi r squared. Pi r squared is the area of a circle. Multiply that times 4, and you find that's the surface area for a sphere that has the same radius. 4 circles laid, almost painted on top of a spherical shape will give you the surface area. Also, a question that is answered in calculus as a proof on why this works. I'm going to jump down to number 11. Surface area is equal to 4 pi r squared. Okay, be careful here. They've given you another one. My diameter is 1.8, so my radius is equal to 0.9 inches. So we're talking about a marble 2 inches across or so, 1 inch radius. What's the surface area going to look like? 4 times pi times radius of 0.9 squared. Calculator chews on that and tells you that 10.18 inches squared is the answer. So that marble, about 2 inches across, has a surface area of a little over 10 inches. Okay. Let's see what happens when the radius goes from 0.9 to 9 units. So we're doing number 12. Surface area is equal to 4 pi r squared. Okay, that's 4 times pi times 9 here squared. So 81. 1,017.88 feet squared. Interesting. The decimal moved once from 0.9 to 9. The surface area increased by a factor of 100. Interesting, which is 10 squared. Okay, there's some demonstrations for volume and surface area done on the same piece of paper today in geometry class. The video comes in under 12 minutes. Personally, a record for Mr. Mitchell. I hope you guys got a few good examples out of that, and you have good luck with the rest of this assignment. Signing off for now.